Okay, we've seen that to choose 3 from 5, there are 5 times 4 times 3 ways to do it. And 5 times 4 times 3 can be written as 5 factorial over 2 factorial, because we get the 5, 4, 3 if we divide out the 2 times 1. So there's the 2 times 1. Dividing by the 2 factorial gets rid of 2 times 1, leaves us 5 times 4 times 3. Now that's if we choose the 3 in order. If they're not to be chosen in order, then we're going to divide by 3 factorial, because 3 factorial is the number of ways, number of orders any group of 3 can be chosen. So we're going to have 5 times 4 times 3 divided by 3 factorial. We can write that out. And we see that the 3 divides the 3, the 2 divides the 4, leaving us 2, so that we have 5 times 2, or 10. Alternatively, that can be written 5 factorial divided by 2 factorial divided by 3 factorial, which can be written fractional form, 5 factorial over 2 factorial times 3 factorial. And if we write the factorials out, it's going to be very similar to what we've already seen, and we will get 10. Now, we could actually list the ways we can get a group of 3 from 5. The list will only be 10 choices long. So, we'd have 10 possible choices of 3. What if we want to choose 8 people from 100, or 8 of anything from 100 of things? Okay, well, if we choose them in order, what's the expression going to be? Okay, you should pause and work that out. But I'm going to write some stuff here, and I'll be right back, but hopefully you will pause and work it out. Okay, well, if you choose in order, then you're going to have 100 choices for the first, 99 for the second, 98 for the third, on down to 93 for the eighth. And that's how many ways. If you multiply those numbers out using the fundamental counting principle, you're going to find that number's in the quadrillions. Okay, huge number, kind of an inconceivable number. Okay, but if they're not in order, then what would the result be? Well, there are 8 factorial orders in which each group of 8 could have been chosen. So your total number of unordered ways is going to be the 100, 99, 98 down to 93 divided by the 8 factorial. Now this number of ordered possibilities, 100 times 99 on down to 93, is the same as, if I got that, yeah, okay, I wasn't sure the camera, is the same as the 100 down to 93 is the same as 100 factorial, which is 100 times 99 times 98 all the way down to 1, divided by what you get if you multiply 92 times 91 times 90 all the way down to 1. Because in the dots here, you're going to have all the numbers from 92 down to 1, and this denominator is going to divide those out, so you're only left with the numbers from 100 down to 93. Now, 92 times 91 times 90 on down to 1 is, of course, 92 factorial, but in terms of our numbers 8 and 100, that can be written as 100 minus 8 factorial, because 100 minus 8, of course, is 92. So when you do 100 minus 8 factorial, you get 92 factorial, which is the denominator here. And the numerator, of course, we see as 100 factorial. Now, what would the expression be if we wanted the number of unordered possibilities? Well, to get the number of unordered choices, we're going to divide the number of ordered choices by 8 factorial. So we're going to have 100 factorial over 100 minus 8 factorial divided by 8 factorial. Well, that's going to be 100 over 100 minus 8 factorial multiplied by 8 factorial, the whole denominator here. And when we do this, when we write out the factorials and so forth, if we write out all the numbers, every number in the denominator will divide evenly into something in the numerator, so that we don't have to actually calculate 100 factorial, fortunately, because it's an unbelievably huge number, or 100 minus 8 factorial for that matter, or even 8 factorial.